Continue on the story. What if I gave you grams, mass of something, and I wanted to know how many molecules that is? There's no conversion that can go from mass to molecules. The only way you can get to molecules is to go from moles to molecules and use Avogadro's number. So if you're given mass, you have to do a two-step thing. You have to first go from mass to moles and then moles to molecules. So what we're going to do in this video is we're going to use two conversion factors. We're going to use molar mass as a conversion factor, and we're going to use Avogadro's number, all in one problem. Let's say I gave you 10 grams of water, and I want to know how many molecules is that. Okay, so basically you want to go from mass to moles to molecules. That's our strategy, okay? So how do we go from mass, 10 grams of water, to moles of water? We need molar mass. And how do you get molar mass? You go to the periodic table, you add up the two hydrogens and the oxygen, and you get 18.0 grams. So setting up this problem, we've got 10.0 grams of water. The first conversion factor is going to go 1 mole of water is 18.0 grams of water. This conversion factor here, this is molar mass. You guys see what I'm doing? So I'm going to convert my grams of water to moles of water. I'm not going to pick up my calculator yet. I'm going to set up my second conversion factor. So now I can cancel grams. Grams of water cancel with grams of water. And now I have moles of water. I want to end up with molecules. So whenever you have moles and you want to go to molecules or atoms or whatever particles, you use Avogadro's number. So we're going to say 1 mole of water. And why do I put mole down here? Because that's the only way I can cancel it. Is 6.02 times 10 to the 23rd molecules of water. I don't know why they don't abbreviate molecules. It's such a long word, but they just don't. Okay, and now moles can cancel. Okay, perfect. Now you can pick up your calculator and do the math. All right, get my glasses again, and we'll pick it up. So what we want to do is go 10 divided by 18 multiplied by this. There's no exponent down here, so I don't need to use a parentheses. So I'm going to go 10 divided by 18 times 6.02 times 10 caret 23, and I end up with 3.3444 times 10 to the 23rd. Okay, I'm going to limit it to 3 sig figs. Why? Because this is 3 sig figs over here. So my final answer is going to be 3.34 times 10 to the 23rd molecules of water. Okay, so that's how we can go from grams all the way to molecules. Now let's do the reverse. Let's say I was given particles, molecules, or atoms, and I want to go to grams. So I'm going to erase this. And I'm still going to use both conversion factors, but I'm going to do the reverse. Let's say I was given, let's say I was given 1.93 times 10 to the, let's say, 25 iron atoms. Okay, I have this many iron atoms. You know that Fe is iron because you guys have memorized all of these symbols properly, I hope. Okay, so you have 1.93 times 10 to the 25 iron atoms. And my question is, how much do they weigh? Or in another way this could be worded is, what is the mass of 1.93 times 10 to the 25 iron atoms? What is the mass? So We want mass, we want grams. The only way to get to grams is to use molar mass, but we don't have a mole, we have particles. So our strategy is to go from atoms to moles to grams. Okay, to go from moles to grams, you need molar mass. So this conversion factor here is going to be molar mass. To go from atoms to moles, particles to moles, you need Avogadro's number. Avogadro's number. Okay, there's the logic behind all of this. All right, so let's do our setup. I'm going to erase this and start off with the 1.93 times 10 to the 25 iron atoms. So I'm going to go 1.93 times 10 to the 25 iron atoms. Okay, I want to get rid of atoms, so I'm going to put atoms down here. I'll put 1 mole up here. Why? Because in order to go from particles to eventually mass, I have to go through moles. So to go from particles to moles, I need Avogadro's number. So we're going to say 1 mole of iron is 6.02 times 10 to the 23rd atoms of iron. Remember, since we have an exponent, we're going to be putting these in parentheses when we're plugging it into our calculator. Once we do that, in order to go from moles to grams, we're going to put moles here and grams here. We're going to need to go to the periodic table and look at the mass of a mole of iron. So I see here it's 55.85. So I'm just going to round it to 55.9 grams. So I'm going to say 1 mole of iron is 55.9 grams of iron. You could write the whole thing. You could write 55.85 if you want to. That's totally fine. Okay, perfect setup. Atoms will cancel. Moles will cancel. Now we just need to pick up our calculator and plug everything in correctly. So we're going to go 1.93 times 10 caret 25 divided by, open parentheses, 6.02 times 10 caret 23, close parentheses, and then multiplied by 55.9. Okay, I have a number, 1,792.142857. Now, I need only 3 sig figs. So the only way to do this, okay, let me get back to you guys. I'm going to stop here and I will finish it up later.